Hi students, good morning to all. In this class we will discuss two combinations, okay, of chapter 4, okay. What is mean by combinations? Combination is a number of selection, okay, number of selection or grouping of an object, okay. Combination is number of selections or grouping of an object, okay, objects. Here it is denoted by n, c, r, okay. C is called the combination, n is the total number of object, r is n taken at r time, okay. Here ncr which is equal to r n c r, write in step order, okay, step r n c r, okay, n c r. Here n c r can be written as n factorial, okay, n factorial divided by n minus r factorial, n minus r factorial into again r factorial, okay. Here again into r factorial, ncr which is equal to n factorial divided by n minus r factorial into r factorial, okay. Here consider we take three objects, okay, we take three objects. Consider we take three objects a comma b comma c are three objects, okay, three objects. Here we can form of two objects, okay, we can form of total number of two objects, okay. Here n is equal to 3 and r is equal to 2, okay. Here n c r which is equal to n is 3, c r is 2, okay. Here n factorial divided by n minus r factorial, that is 3 minus 2 factorial into again the factorial, okay, into 2 factorial. Here then the result is 3 factorial is 3 into 2 into 1. Here 3 minus 2 factorial is 1 factorial, 2 factorial is 2 into 1. 2 ones are cancelled, 3 divided by 1 factorial is 1, 3 by 1 is equal to 3. It means we get 3 number of grouping, okay, 3 number of grouping, that is we take a b, okay, a b or a c, okay, or b c. This is an 3 result, okay, total number of ways a b or a c or b c. These 3 are the number of selections, okay, number of selections. Here already we know that permutations, okay, permutations. Here we take n is equal to 4 and r equal to n equal to 3, r equal to 2, okay. Here n p r which is equal to 3 p2, okay, 3 p2 means 3 into 2. Only we take two object at same time, 3 into 2 which is equal to 6 ways, okay. 6 ways are here written. A b is one way, okay, a b is one way, and the another one is b a, okay, another one is b a, then a c, okay. Here c a, next one B C, here C B, here A B B A, A C C A, B C C B are the arrangements. Okay, arrangements. Here A B is it means in the first place the object A is placed. Okay, here in the second place object B is placed. In the next one is in the first place object B is present, and the second place object A is allowed. Okay, allowed, it means present. Here A B not equal to B A. Okay, here totally we can two different ways similarly to the same process, but here A B means we can select two object. Okay, A is one object and B is another one object, and B A. Okay, B A is an B A is the selection of two object B and A, both are same. Here A B B A are arrangements. Okay, arrangements are different. Here selection of object are same. Okay, next we will discuss difference between permutations and combinations. Okay, here what is the use? Okay, what is the use of permutations? It means what is the use of permutations is arrangement of elements. Okay, arrangement of elements. Of objects. Here number of selections are grouping of objects. Okay, selection of objects. Here where is use? Okay, where is use of permutations means the arrangement is the matter. Okay, arrangement is the matter. That means order. Okay, order is matter. Matter means consider. Okay, consider into here of permutations. Here arrangement of objects, does not matter. Okay, does not matter because A and B are the objects. Okay, A and B, A is one object, B is another one object. Here then another one is B A means B is one object, A is one object, that is both are the same selection. Okay, same selection. Here A B is equal to B A, both are same, that is order is does not matter. Here permutations A B is one order. Okay, A B is one arrangement, another one arrangement is B A is another one arrangement. Okay, here N P R which is equal to n factorial, that is n factorial divided by n minus r factorial. Okay, n minus r factorial. Here n C R which is equal to n factorial. Okay, n factorial divided by n minus r factorial into r factorial. Okay, here NPR is an arrangement of a list. Okay, arrangement of a list or row. Here some standard value is NP0. Okay, NP0 is 1. Here NC0 which is equal to 1. Then NPN which is equal to n factorial. Here NCN which is both are same, number of distinct objects taken n, okay, at the same time, which is equal to 1. Okay, here the next one is the most important one. Here we take can be formed 3-digit numbers. Okay, can be formed 3-digit numbers. This is the first position, the second position, third position. Here given digits are 0, 1, 2, 3, 4, 5. Okay, here first filling in the first boxes. Okay, and the second filling, third filling. In the permutations here, first filling is done. Okay, done. Then go to the second position. It means the process is done. After one we take after one. Okay, that is 1 by 1. Okay, 1 by 1. Here combinations is simultaneously. Okay, simultaneously we can select the total number of objects. Okay, next go to properties of combinations. In the property number 1, nc not equal to 1, subdivision 2, ncn is equal to 1, subdivision 3, ncr equal to n into n minus 1 into and so on n minus r plus 1 divided by r factorial. Here proof, we know that the expansion of ncr, which is equal to n factorial divided by n minus r factorial into r factorial. Okay, in the first subdivision n c naught. Okay, the position r is 0. Here n factorial divided by n minus 0 factorial into 0 factorial. Okay, n minus 0 is n factorial. N factorial are cancelled. Then the value of 0 factorial is 1. That is 1 divided by 1, which is equal to 1. Okay, in the second subdivision ncn. Okay, ncn we can be written as n factorial divided by n minus n factorial into n factorial. Okay, n minus n is 0 factorial. N factorial divided by 0 factorial into n factorial. Here n factorial are cancelled. The value of 0 factorial is 1. 1 divided by 1, which gives to 1. In the third subdivision, ncr, which is equal to, here n the total number of object, r is the taken r object at a time. It means n into n minus 1 into n minus 2 into and so on up to n minus r plus 1. Okay, that means r position, first position, second position, third position and so on up to the rth position divided by r factorial. Okay, divided by r factorial, that is the ncr. Okay, in the property number 2, ncr is equal to nc n minus r. We can find the left hand value of left hand side, that is ncr, which is equal to n factorial divided by n minus r factorial into r factorial. This is equation number 1. Now we take RHS side, RHS, that is nc n minus r, which is equal to n factorial divided by n minus r factorial. Okay, n minus r is n minus r factorial into r factorial. Okay, into r factorial, that is n minus r factorial. In the denominator, product of minus 1 into the brackets. Okay, into the brackets, that is n factorial divided by n minus n minus of minus plus r factorial into n minus r factorial. N minus r factorial. Here plus n minus n are cancelled, remaining r factorial, that is n factorial divided by n minus r factorial into r factorial. This is equation number 2. From equation 1 and 2, right hand side, the value of right hand sides are equal means we can equate the left hand side, that is equation from 1 comma 2. From 1 comma 2, which is equal to ncr is equal to nc n minus r. Then the results are equal, hence proved. Okay. Next, property number 3, if ncx, which is equal to ncy, then either x equal to y or x plus y is equal to n. Okay, solution, given that ncx which is equal to ncy. Okay, we know that the property number 2 is ncx which is equal to nc n minus x. Okay, n minus x. Using the property into here, ncy which is equal to ncy which is equal to nc n minus y. Okay, n minus y. In the left hand side, ncx. Here it is can be equal to, which can be equal to x equal to y. Okay, ncx equal to ncy, which is either x equal to y, or otherwise here we take x equal to n minus y. Okay, x equal to n minus y. Okay, in the first we equate to here, in the next one equate to into here. Here x equal to n minus y. On the y goes to left hand side, that is x plus y which is equal to n. Okay, x plus y which is equal to n. In the otherwise x equal to y. In the property number 4, ncr plus ncr minus 1 which is equal to n plus 1 cr. Okay, now we take LHS, that is ncr plus ncr minus 1. Okay, in the first term we can rewrite to using the combination formula, that is n factorial divided by n minus r factorial into r factorial. Okay, in the plus, in the second term we can write in using in combination formula, that is n factorial divided by subtraction of n and r, that is n minus r minus plus 1 factorial into r minus 1 factorial. Okay, r minus 1 factorial. In the first and second term, comparing to the denominator n minus r factorial into r factorial. Here n minus r plus 1 factorial into r minus 1 factorial. In the first term we can change to the r factorial. Okay, we can rewrite to here n factorial divided by n minus r factorial into r factorial, we can rewrite to r into r minus 1 factorial. Okay, r into r minus 1 factorial, plus in the second term n factorial divided by r minus 1 factorial is doesn't change. Okay, doesn't change, only we can change to n minus r plus 1 factorial, that is n minus r plus 1 into n minus r factorial into r minus 1 factorial. Here comparing to the denominator, we take common of n minus r factorial, r minus 1 factorial of denominator, and the numerator is n factorial. Take outside of two terms, which gives to n factorial divided by n minus r factorial into r minus 1 factorial. Okay, this is the common term of two common, take outside the common. Okay, this is the common. Here in the first term only remaining of 1 divided by r, plus in the second term 1 divided by in the n minus r plus 1. Okay, n minus r plus 1. Here take LCM, that is using cross multiplication, that is n factorial divided by n minus r factorial into r minus 1 factorial. Okay, using cross multiplication, 1 into n minus r plus 1 is n minus r plus 1, plus 1 into r is r, divided by r into n minus r plus 1. Okay, then the numerator minus r plus r are cancelled, then the remaining is n factorial divided by n minus r factorial into r minus 1 factorial. The numerator is remaining n plus 1 divided by, then the denominator is r into n minus r plus 1. Okay, here the n plus 1 is product into numerator into n factorial is n plus 1 into n factorial. Then the denominator is, the r is like into here, n minus r plus 1 is like into here, that is n minus r plus 1 into n minus r factorial into r into r minus 1 factorial. Okay, r into r minus 1 factorial. Here we know that 5 factorial is which can be written as 5 into 4 factorial. Okay, 5 into 4 factorial. And similarly to the same process, n factorial which is equal to n into n minus 1 factorial. Using the formula n plus 1 into n factorial, which gives to n plus 1 factorial. Okay, n plus 1 factorial. Then the denominator is n minus r plus 1. In the next term, n minus r factorial is, which can be written as n minus r plus 1 factorial. R into r minus 1 is r factorial. Okay, it can be written as n plus 1 factorial, n plus 1 c r fact c r. Okay, c r. We take LHS now, change to the RHS. LHS equal to RHS, hence proved. Next, property number 5, NCR which is equal to n by r into n minus 1 cr minus 1. Here proof, we take left hand side NCR, okay, LHS, okay, NCR which is equal to n factorial divided by n minus r factorial into r factorial. This is equation number 1. Now we take RHS, that is n by r into n minus 1 c r minus 1. Okay, the n by r into, using the formula of NCR, that is n minus 1 factorial divided by n minus r. Okay, n minus 1 minus r, minus of minus plus 1 factorial into r minus 1 factorial. Okay, r minus 1 factorial. Here plus 1 minus 1 are cancel, then the remaining is n divided by r into n minus 1 factorial divided by n minus r factorial into r minus 1 factorial. Okay, r minus 1 factorial. The product of n into here, that is numerator, n into n minus 1 factorial, which can be written as n factorial. In the denominator, the product of r like into here. Okay, that is n minus r factorial into r into r minus 1. R into r minus 1 factorial, which is equal to r factorial. Okay, here r factorial. This is equation number 2. From equation 1 comma 2, then the comparing of equation 1 and 2 of right hand sides are equal, we can equate to the left hand side, that is NCR which is equal to n by r, n divided by r into n minus 1 c r minus 1. Okay, then the result are equal. Next, exercise 4.3, question number 4, prove that 15c3 plus 2 times of 15c4 plus 15c5 which is equal to 17c5. Okay, proof, we take left hand side, we take LHS, that is 15c3 plus 2 times of 15c4 plus 15c5. Okay, here 2 times of 15c4, that is 15c4 plus 15c4, isn't it? Yes, 15c3 plus 2 times of 15c4, we can write to 15c4 plus 15C4. Okay, here plus 15C5. Here using in one property, that is NCR plus NCR minus 1. Okay, NCR plus NCR minus 1, which is equal to N plus 1 CR. Okay, N plus 1 CR. Similarly, comparing of two terms, that is 15C3, 15C4. Here this is like as NCR. Okay, here NCR minus 1. Okay, NCR plus NCR minus 1, which can be written as N plus 1 CR. Okay, N plus 1 CR. Here N is 15, N plus 1, 15 plus 1, C, R is, here R minus 1 is 3, R equal to 4. Okay, R equal to 4 plus, then the remaining two terms here using again into these properties, that is N here like as NCR, here like as NCR minus 1. Okay, plus two terms, that is likes N plus 1, 15 plus 1, C, R is 5. Okay, R is 5. Simplify, 15 plus 1 is 16C4 plus 16C5. Okay, again using these properties, here like as NCR, here like as NCR minus 1. Okay, NCR minus 1. The N is 16. Here N plus 1 is N plus 1 CR. That is N plus 1 is 16 plus 1 is 17. R is 5. Upon 17 C5. We take LHS, change to the RHS. Okay, LHS equal to RHS. Hence proved. Next, exercise 4.3, fifth problem. Prove that 35C5 plus summation of R equal to 0 to 4, 39 minus R C4, which is equal to 40C5. Okay, here we take left hand side, we take LHS, that is 35C5 plus summation R equal to 0 to 4, 39 minus R C4. Okay, here the first term, that is 35C5 plus summation, we remove the summation, means substitute the value of R 0 to 4. Okay, substitute R equal to 0, that is 39 minus 0 C4 plus substitute R equal to 1. Okay, substitute R equal to 1. 39 minus 1 C4 plus 39 minus 2 C4 plus 39 minus 3 C4 plus 39 minus 4 C4. Okay, this is the summation. Okay, this is the summation of R equal to 0 to 4. Here simplify, you get 35C5 plus 39 minus 0 is 39C4, 39C4 plus 39 minus 1 is 38C4 plus 39 minus 2 is 37C4 plus here 36C4 plus 35C4. Okay, here grouping of two terms, that is 35C5, 35C5. Okay, that is 35C5 plus 35C4. Okay, plus the next arranging in the order of the numbers, that is 36C4 plus 37C4 plus 38C4 plus 39C4. Okay, 39C4. Here 35C5 plus 35C4 using the property is here the property is NCR plus NCR minus 1, which is equal to n plus 1 CR. Okay, n plus 1 CR. Here NCR like as NCR plus NCR minus 1. Okay, using these results, that is n plus 1 CR, that is 35 plus 1 is 36C. This is R minus 1. So 36C R is 5. Okay, plus the next term 36C4. Okay, plus 37C4 plus 38C4 plus 39C4. Here again using these properties, 36C5 plus 36C4, which gives to 37C5. Okay, 37C5 plus the next term 37C4. Okay, plus the remaining term is 38C4 plus 39C4. Here using these properties into here, that is like as 38C5. Okay, 38C5 plus 38C4 plus 39C4. Okay, similarly using these properties into here, then the result is 39C5 plus 39C4. Okay, here again using these properties, that is 40C5. Okay, 40C5. We take the left hand side. Now get the result is RHS. Okay, RHS. LHS equal to RHS. Hence proved. Next, problem number 6. If n plus 1 C8 ratio n minus 3 P4, which is equal to 57 ratio 16, find the value of n. Okay, solution given in ratio form, we can write to A is to B, which is equal to C is to D. It can be written as A by B, which is equal to C by D. Okay, the given n plus 1 C8 is to n minus 3 P4, which is equal to 57 is to 16. Okay, using this concept, that is n plus 1 C8 divided by n minus 3 P4, which is equal to 57 divided by 16. Okay, using the formula of combination, that is n plus 1 factorial divided by n minus r. Okay, that is n plus 1 minus 8 factorial into 8 factorial. Okay, into this is the denominator. Okay, denominator, then the result is fraction p by q. The product to the product like as reciprocal, that is q by p, that is 4 factorial divided by then the denominator is n minus 3 minus 4 factorial divided by n factorial. Okay, n minus 3 factorial, which is equal to 57 divided by 16. Okay, then the numerator and the simplify on the left hand side is n plus 1 factorial divided by n plus 1 minus 8 is n minus 7 factorial. Okay, n minus 7 factorial into 8 factorial into n minus 3 minus 4 is n minus 7 factorial. n minus 7 factorial divided by denominator is n minus 3 factorial, which is equal to 57 divided by 16. Here n minus 7 factorial, n minus 7 factorial are cancelled. N plus 1 factorial we can rewrite to n plus 1 into n into n minus 1 into n minus 2 into n minus 3 factorial divided by 8 factorial into n minus 3 factorial, which is equal to 57 divided by 16. Here n minus 3 factorial, n minus 3 factorial are cancelled here. Then the denominator have 8 factorial goes to right hand side, that is n plus 1 into n into n minus 1 into n minus 2, which is equal to 57 divided by 16 into 8 factorial is 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. This is the numerator. Okay, here 16, 8 into 2. Then the remaining result is 57. We can split into 3 into 19. Okay, 3 into 19. Then the remaining result is 7 into 6 into 5 into 4 into 3 into 1. Okay, in the left hand side n plus 1 into n into n minus 1 into n minus 2. Okay, here we can change to the right hand side of product of 4 numbers. Okay, product of 4 numbers, because in the left hand side have product of the 4 factors. So right hand side we can change it to the product of 4 numbers in descending factor. Okay, descending factor. Similarly, like as the right hand side change to the product of 4 number is descending order. Okay, descending factor is like as descending numbers. Suppose the factor is increased, means that is ascending order, means then the right hand side change to the product of the ascending numbers. Okay, here 7 into 3. Okay, 7 into 3 is 21 into 5 into 4. Okay, 5 into 4 is 20 into 19 into 6 into 3, 18. Okay, then the left hand side is n plus 1 into n into n minus 1 into n minus 2. Here in the product of 4 factorial, then product of 4 factor, which is equal to product of 4 numbers. Okay, this is descending order. Here the product of 4 numbers is in descending order. Similarly to the same process, we can equate the first factor is equal to first number, second factor equal to second number, third factor is equal to third number, fourth factor is equal to fourth number. Okay, all the process have the same result, that is n equal to 20. Okay, similarly we get n equal to 20. Okay, next question number 7. Prove that 2ncn, which is equal to 2 power n into 1 into 3 into 5 into and so on, 2n minus 1 divided by n factorial. Proof. In the left hand side 2ncn, which is equal to 2n factorial divided by 2n minus n factorial into n factorial. Okay, then the numerator is 2n factorial divided by 2n minus n is n factorial into n factorial. Okay, then the numerator is 2n factorial, means 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 into and so on, 5 into 4 into 3 into 2 into 1. Okay, then the denominator is doesn't change, that is n factorial into n factorial. In the numerator we can split into product of odd numbers and product of even numbers. Okay, here product of even number is 2n into 2n minus 2, 2n minus 4 and so on, 4 into 2. Okay, this is the product of even numbers. Okay, and product of odd number is 2n minus 1, 2n minus 3 and so on, 5 into 3 into 1. Okay, then the denominator is n factorial into n factorial. Here the product of even numbers, all terms is the product of, that is multiples of 2. Okay, multiples of 2. We take 2 outside. We take outside number 2 in the all terms. Okay, here take 2 here. For example, 2 into 4 into 6 into 8. Okay, we take only 4 numbers, product of the 4 numbers. We take 2 into outside, that is 2 into 2 into 2 into totally 4 numbers, means it's like as 2 power 4 into in the remaining 1 into 2 into 3 into 4. Okay, similarly to the same process, 2 outside in the n numbers, like as 2 power n into 1 into 2 power n is 1 into 2 into 3 into and so on, n minus 1 into n. Okay, in the odd number is doesn't change, that is 1 into 3 into 5 into and so on, 2n minus 3 into 2n minus 1. Okay, then the denominator is n factorial into n factorial. Here 1 into 2 into 3 into and so on, n minus 1 into n is n factorial. Okay, n factorial are cancelled, then the remaining result is 2 power n into 1 into 3 into 5 into and so on, 2n minus 3 into 2n minus 1 divided by n factorial. Okay, LHS equal to RHS. Hence proved. Next, question number 8. Prove that if 1 less than or equal to r less than or equal to m, then n into n minus 1 into c r minus 1, which is equal to n minus r plus 1 into n c r minus 1. Okay, proof. First we take in left hand side, that is n into n minus 1 into c r minus 1. Okay, which is equal to n into n minus r c r minus 1 using the formula of combination, that is n c r n minus 1 factorial divided by n minus r is n minus 1 minus r minus of minus plus 1 factorial into r minus 1 factorial. Okay, r minus 1 factorial. Okay, then the numerator is n into n minus 1 factorial divided by, then the denominator minus 1 plus 1 are cancelled, then the remaining is n minus r factorial into r minus 1 factorial. Okay, n into n minus 1 factorial, which can be written as n factorial. Okay, n factorial divided by n minus r factorial into r minus 1 factorial. This is equation number 1. Okay, now we take RHS, that is n minus r plus 1 into n c r minus 1. Okay, n minus r plus 1 into, using the formula of NCR, it can be written as n factorial divided by n minus r factorial, n minus r minus of minus plus 1 factorial into r minus 1 factorial. Okay, here n minus r plus 1 into n factorial divided by n minus r plus 1 factorial into r minus 1 factorial. Here we can change into the factorial of n minus r plus 1 factorial. Okay, change into these terms only. Here n minus r plus 1 into n factorial divided by n minus r plus 1 into n minus r factorial into r minus 1 factorial. Then the numerator n minus r plus 1, denominator n minus r plus 1 are cancelled. Then the remaining is n factorial divided by n minus r factorial into r minus 1 factorial. side. This is equation number 2. From comparing equation 1 and 2, then the value of right hand side n factorial, n minus r factorial, r minus 1 factorial are cancelled. Therefore, equating the left hand side, then prove the result. Okay, from equation 1 comma 2, right, RHS are equal means we can equate the LHS, that is n into n minus 1 c r minus 1, which is equal to n minus r plus 1 into n c r minus 1. Okay, hence proved.